Hey everyone, welcome back to the R Masterclass course. Today we will be looking at R visualization, and this is one of the most important topic in this course. This lecture and the upcoming two lecture would be one of the most important lecture in this course. And with this, let's get started. So you might be wondering why R visualization is one of the most important topic. So let's get our hand dirty. So if I show you this graph, you could start automatically interpreting things, and basically this is the visualization from a data set from the salaries of a college professors. And here you could see, you could, if I show you this, you could automatically interpreting lot of things, such as that professors are in university there are much count of professor, then we have the count of assistant professor is more than we have associate professor whose count is third. From this graph you could also interpret things that male professor is greater than female professor, because you could see that this bar plot have more count of male professor. So male professor count is greater than female professor. And if we look at this plot, you could see that the most salaries are in the range of 50k to 100k, and the max that goes around is around maybe uh, 300k. This could be 300k range, who are in the profession about 40 to 30 years in this profession. You could see that their age is around like 30 to 40 years age, and they are earning about, the highest one they are earning about is 300k. And I don't need to learn any new thing, just I'm interpreting things from this graph. And here is a box plot graph, basically a plot with having a blocks plot, and this line shows you the median, the black line, and this is the highest and this is the lowest range, and this is the most of the part lies in. Similarly for the female, this is the most part that lies in, and you could see that the male average is greater than the female average. So you could say that from this graph we could also interpret that males professor earn more than female professor. Here we have the highest in the range of, you could see that the max was the around 300k, but the max highest in this line is around 200k. Then the lowest is at 50, above 50k somewhat, it's around something 50 to 53k, and most in lies in the region about around 70 to 140k. That's the average that male professor and female professor earns, and basically female professors earns little less. And basically you could interpret lot of things just by looking at this graph. So you know that pictures speak thousand words, and by using our visualization you could do this. So now let us see what we are going to learn in this course. So what are the outcome of this course? First, data visualization is a crucial part of data analysis that will allow you to better understand and interpret data. So if you are into ML engineering, or are you into data science, or are you a researcher, or are you into any kind of AI ML or into deep learning, data visualization will help you a lot, because once you need to create a model, you need to know about data sets, and if you know how what are the trends in the data sets, you could create a better model. Other, if you don't use data visualization, interpreting data from directly from numerical is a very challenging task, and it's none too impossible. Now, if humans are way better in recognizing pattern in visual data than in numerical data. So if you have a visual data, it will help allow other people to discover the relationship, identify errors, and understanding the trends in your data set that you are using for visualization. Next, I cannot emphasize on this part, but there is always a saying that a picture says thousand words. So visualization have a stronger impact than a text or a numerical. So if you, which have a better effective way for storytelling and persuasion. So if you want to tell someone uh, your about your findings, a data visualization would make it very easier for other person to get it understand. Now let us know about the last point. Due to this point, persuasive power of visualization, researchers, data scientists, ML engineer, deep learning, and in almost all pharma industries, I have seen that they prefer our language for visualization. With this, let's get started. So before we move on to the R visualization, we should know what are the general steps for the R visualization. So first, we would have some data, some kind of data sets, and this data set could be data set of, for example, the car. The data set of the car may contain number of doors, mileage, uh, safety, and so on. And then we apply data transformation. What does data transformation means? We clean the data set. We clean the data set. We check if there is any null values, or is there any values which will affect the whole data transformation, or if there is a null value, we might remove it, or we change it with any other random values or mean average values. And then we visualize the model, visualize the data sets, we get the trends, we get to know okay what's happening, and then we got to know the what data set is representing. Then we go on to the model part. So here is the whole general overview. Now with this, let's get started directly with the R Studio. So first you need to open R Studio. So the first thing we need to do is for our visualization is we need to install some packages. And to install packages, we know that install.packages and the package name would install it. So here are the general packages that we required, and we are going to import this from CRAN, that is maintained by R, and the full form of CRAN is Comprehensive R Archive Network, which is maintained by our open source community. So basically, these are the packages we are going to use, and don't get overwhelmed. We are going to check one each visualization library package one by one when we are going to import the data set and use the visualization tool. So first, now let us run this, and I will paste this code into the comment section, and I will post this post GitHub repo, and this way you could copy this code and run into your machine. So the shortcut key we know, Control Shift Enter. Trying to It's downloaded, content type, and it will take some few minutes. Once it's get downloaded, so what basically it does is it's try to fetch to that R package. It downloads it into their R repository, which is in our local machine. We have this packages installed. So when we mention this packages, that is fetched from there. So basically, let us see if it's have been installed or not. It's taking time. So I will pause this video and we'll join back once this gets installed. So once these packages have been installed, we need to add few more packages. So let me comment this out, Control Shift C, and this will comment whole lines that we have selected. Then this is the packages that we need from GitHub, And basically what this code is doing is concatenate all this repos link, and then from the remotes we call the public method install GitHub, and it install all this dependency. So we know what we need to, we know the shortcut to compile, Control Shift Enter. Packages code required but is not installed, we could install it from here. Once it's installed, we could install all the GitHub repos. And here in the background console, you could see all this GitHub packages is getting installed. So now let us wait for a few seconds and let us see how much time it will take to install all this. Now it's time to look at how you could import the dataset in R. So to import dataset in R, basically we need to have a CSV file, text file, or Excel file. We need to have some data. So to have some data, I already have the salary data set that we are going to use. So here's, I have already downloaded it, the data set, and I will provide you the link. You could download it from the given link, or you could went out to the GitHub channel and you could copy the link and download the data set from there. So me copy this, and then you need to copy this to your working directory. What do I mean by working directory? So when the file where you have saved this R script. So suppose you created this file and you saved in this R visualization. So this is your working directory. So you need to save those file there. So why? Because you could easily import that file from there, that particular path. So because it will be very easy, you don't have to mess around and add an attribute that the where the file is. Basically it will be the same folder in which the code is. So you could just say demo, and here I already created a R file, and I'm going to save this to my working directory where I have saved the code. So I will go to 02 master class, coding, and here is my data set. So once you have pasted it, you need to make it your working directory. So how to make this your working directory? So suppose I am here. First you need to go to the path where the file you have stored. So I have stored in desktop folder 0 to hero in master class, R master class, and in R coding I have saved this file. So the first thing I have to do is I have to make it a working directory. To make it my working directory, you need to go to this gear icon which is known as setting, and here in this you could see set as working directory, and here you could set this as working directory, or you could go to console and type this set working directory and the path to your file where you have saved this. So we'll remove this, and now to import this file we need to have a library. So first library we need to have is read R, and you could see here it's already providing some suggestion. The goal of read R is to provide a fast and friendly logo. This is logo which is broken way to read rectangular data like CSV, TSV, and FWF. It is designed to flexibly parse many types of data found in the wild while still cleanly handling when data unexpected changes. So it helps you to read the data from CSV, and if your CSV is messed up, it also fails, and through their function you could handle those failures. Let us declare our variable in which we need to save the values. So salary, in which we will save values, read CSV, and you could see that it is importing this method from read R, and it requires file, and mostly it will have all the default values, so we don't need to change anything. We just passed our file name that we need to import salaries.csv, Let me check if there is any typo in the file name. So there is no typo. Let us save it. We know the shortcut key to clear the console, that is Control L. Once that's done, save the file, Control L. We could see our variable salary have 397 observation in the environment tab once you came, and here you could see it has rank, discipline, year since PhD, year of service, sex, and salary. Now we know how to read CSV file, and what does CSV file means? Basically comma separated values. And if we need to read TSV files, what do you mean by TSV? Basically a tab separated values. And what does TSV is for stands for the .txt extension, basically your text file. So here in this URL I will provide you in the link. It have those same CSV values in text format. Basically you could copy, and in your working directory here you could create a new file with name text file. Here new file, and in the text document you could create those new files and basically paste those values. And once you come to your editor, you could see all those file have been already imported. So here you could see that there is some typo in this, that is salaries.txt.txt. This is not a good thing because it's will confuse the editor that what it is. So in the naming part we need to remove .txt, basically a normal convention, basically capital S and a capital name of the file. In first letter should be the camel case, and all the other things should be in small. And if it's another word, it should be a in caps. So basically if it's new text document, basically you should avoid all the time space because it would mess in the data set when you import, and it should be camel case. So first letter N should be capital, then the text words in this, the T should be capital, and in the document D should be capital. Because of the camel casing, the first letter should be capital. Once we did this, we know what we need to do. So from the read T, let us create a new variable. Let us say salary TSV, and what it does is basically import from tables separated values. So, and here you could see that we are getting a hint suggestion that you need to do same thing that you did for salary. So salary dot txt, Control S. Let me remove all the environment variables so it is easy for to get the environment values. And here you could see the same values have been getted in salary TSV. Now it's time to learn about declare package. So what do I mean by declare package? So if you come to Google and search for dplyr, it will open a website that is dplyr.tideverse.org. Basically, dplyr package provides us data manipulation techniques to manipulate your data. So we have looked how to import data. Now it's time to look at how you could transform data. So this is where dplyr came. So it provide us basically 5 functions, and we are going to look each one in much detail. So first one is mutate, and we are going to look at some overview, and then we are going to apply it. So mutate basically help you create a new variable and you want to change some values into it. So basically if there is a salary and you need to create a new column with salary doubled into it, you could use mutate. And then we have select, basically to select the columns, and then we have filter, which we need to filter out data. If the salary is greater or 50, then particular salary bar, we need to get only that person, so we could use filter. Then we have summarize, that give us the summary value, basically a mean value of all the data set. And then we have arrange, if we need to change the rows or columns of the data. So first, let us start with the select one. What does select do? Basically, selects any column, row, column of the data set. And for this, we are going to use already imported data from that dplyr. It already provides star war character. It have name date, which contains the name of the character, height, which provide the height of the character, mass, weight, hair, color, skin, birth year, sex, gender, homeworld, species, films. And now let us first save it and create our new file. We know the shortcut what it is. Control Shift N, and first let us save it with the file name our visualization dplyr. Now first we need to import dplyr package. We know how to import it. Library dplyr, which it imports it the library. We define new data in which we need to first see what does Star Wars data contains. Then we will select it. So first, what we'll do is we create Star Wars data. Star Wars data. What it particular does it does just Star Wars data. You could see it imposed from the dplyr package. So let us clear the environment tab that we need to import. We'll remove clear or console and then run our program. You could see we have Star Wars, and we could open this data set by clicking on the column tab. It gives us the name, height, mass, hair color, and you could see here are some NA values. We will see how we could handle those. And then we have all the films that it contains, vehicle it has, starships that it contains. So I haven't watched Star Wars films, so forgive me if I skipping some main parts of the Star Wars data. So now what we need to do is we need to select the data only the, let's say we need to select only name, height, mass. So what we need to do, we create new data and then we call select. We could see it from dplyr, and then we need to pass the column that we need to. First we need to pass the data set that we need to do this. So we pass the data set that we need to do this. Either you pass the Star Wars or you could pass Star Wars data. Basically both contain same data columns. And now from this we need name, height, mass. So we will import name, height, mass, and then save it, and we will see the values in the environment tab. So let us clear our data, run it. You could see here 3 variables, 87 observation, and it contains all the value. Now it's time to learn about filter function. What if we need only mass in which the mass is greater than 77? Now it's time to learn about what does mutate does. So basically mutate is basically you to transform your current data set, or you want to add new values to data set. You could do this with mutate. So let's suppose we create new data too. Basically what we did here is we going to mutate or current new data that we have extracted from Star Wars, and what we are going to do is basically transform that current variable. So we call height is equal to height into 2. We basically increased by 2, for example, and we did similarly for mass. We increase it by 2. We save it, enter it, and we see the new data 2. Let us add new data 2 variable to it. So why did you add 2? Basically to find the difference. So I will run it, Control Shift Enter. You could see new data 2. 3 values. Here we have height doubled, and if you see new data, you could see the height has been doubled in new data 2. So now let us go back to where we were, our data visualization. Now let us look onto the filter. Basically, if we need to extract the data values from your data set, we use filter based on a certain condition. So let's suppose we want to extract new data 3 from filter. You could see that it requires data and some condition. So, and basically preserve is that the condition of the row data column is needs to be changed or not. So we are not changing, it's by default it's fault. So new data 2, let's take new data, basically the real original values, and we say we take height where should be greater than 172. We run it. Basically, let me add new data 3 so we could find the difference between new data 3, and here we will get all the values greater than 172. Now it's time to learn about the other two, that was summarize and arrange. Now let's look at how you could use summarize. So let us create a new variable, new data 4, and we call summarize. You could see that it is called from dplyr package. If you need more help, you could run basically call more help like summarize, and if you press additional help, you get the documentation open in your help tab, which you could use to find to know okay what is happening. So here basically you could see what are the data parameter it accepts. All this thing it accepts mean, all this thing we are going to use one of these example. So what we are going to do is basically, let us go back to the tab, summarize, and then we pass new data, and then we summarize mean height is equal to mean of height that we have selected, and in this we pass na dot rm is equal to true. What it basically does is it says if the values in the height is null, it will remove it. We do for similarly for mean mass, for mean mass na dot rm is equal to true. Then we save it, control enter, we get new data 4. Let us open it, we get the value summarized into single line. That is what summarize does. Here we could see that mean height is around 174 and mean mass is about 97 kilos. Now let us look at how you could use arrange. Basically arrange is used to sort your data into particular format. So you want to, if you want to show your data by ascending height of mass, you could use arrange. So let's suppose we call new data 5 and we want to arrange this data set based on the mass. Suppose we want to arrange it by suppose descending order of mass. So we call new data and then we call dsec, basically by dsect, and we pass height. We save it and you see new data 5 in the tab, and here you could see all the values based on the descending value of height. So you could see the height 264 is highest, and then in the last we get the lowest. So with this we could wrap up the data format section, and now in the next part we will look on to how you could use ggplot library to visualize data set. Now it's time to learn about ggplot2. So ggplot2 is one of the most used library for data visualization in R, and we are going to look this in very depth. So here is ggplot2 documentation, and here in the overview you could see ggplot2 is a system for declarative graphics. Based on grammar of graphics, you will provide the data to tell ggplot how to map variable to this their aesthetics. So in starting of this lecture, we have already seen download install this package. If you have not, you could just directly on install by install.packages ggplot2. So you could do this by opening RStudio, and once you are done, and then install dot packages ggplot2. What it will do, it will go to that package directory and download it. And we already have this package, so we don't need to, it will take time. So once it's downloaded, they also provide cheat sheet, and here you could see what they basically do is let it load. So here's the documentation how you could use it. So basically you need to use geom, which we are going to look this in shortly in very much details. And basically you need to provide the data set and then the aesthetic how the data should look like, and then you should call geom point. So now it's time to use the ggplot2. So here we'll be using this documentation, and here now I will give you one technique to use directly dataset from online. So here let us define the URL, and this URL is a string of the location of the file, and then we'll call, basically this data set is of insurance, like, and this data set contains male, female, age, BMI, children, smoker, region, and expenses. So basically we need to read this data set. So let us declare a variable that hold this data set. So we know how to read CSV file, read it should be, let me include dplyr package library, and then we import ggplot library 2. Once this done, so let us read CSV, and then we pass URL and also enter. We get the data set values. Here we could see all the values have been imported in R. Let us save this. Once this done, let us create one more data set. Let us call it uh, obese. So here we have insurance data set, and we know if BMI is, there is a standard rule that if BMI is greater than 30, it will be considered obese. So we will create a new column known as obese, and to do that we are going to use column method. That means to create, if there is no column, then create one obese, and we have a obese column, then we call if else, and here you could see if else condition. Let us take this from dplyr package, and what we need to do is we will pass our insurance, and from this we will fetch, to fetch the column, we know we need to use dollar method, and then from this we need to get the BMI. So we'll get the BMI, and then if this greater than 30, this should be inside obese, else not obese. Obese. So basically we will put in double tag, and here we have a typo error, unexpected token. So to do this, so to remove this unexpected token, we just need to remove this brackets and it should be fine. And then we'll clear our console, control shift enter, insurance undefined. We have a typo here because it's saying that insurance, which is a typo. We have again a typo. Let me just copy paste it. Let us copy paste. We get the okay. So here in this we also have a typo. And then once it's run, we could see our data set, and it have an obese column which contains if BMI is greater than 30, it's obese or not. Now it's time to use our ggplot library. So now let us try to use our ggplot library. So now we have looked how to create a new column and fetch detail from the column using dollar method. Now it's time, let us plot something. So let us try to plot age versus expense and see if age increase does expenses also increases. Let's try to see that. And to do that, we need to have a library called ggplot2, and we already in the starting point we looked at what is ggplot library does. So we will call ggplot uh, from ggplot2 function library. So we will call ggplot. Okay, let's just see why it's ggplot. Here we could see the documentation. Basically you need to provide data mapping. Aesthetic, basically you need to provide an aesthetic is x and y, and then that will create your plot. Now let us create your plot. Data we will provide insurance, will on mapping we provide our aesthetic to be x will be our insurance, age, insurance, dollar, and then here we will provide expense. Let us see, save it. Now you will be surprised. Okay, nothing have been plot. Yes, nothing have been plot. We need to use one more method, that is geom. Basically geom provides lot of function methods that uh, what to show to the user. Basically if we need to show the points, we will call geom slash point. So we need to add geom method inside this. So basically it provides bunch of function geom slash underline, and then you have lot of methods to create graphs. Basically from this, like they provide the error plot, dot plot, histogram, and from this they will provide also you the line, but we need only point. So we'll see, and here we got our plot. So now in this plot we could see that expenses generally tend to increase over the ages. So and mostly it's yeah, it's does increases generally over the time, uh, and it is maximum here we could see in this, but we are not able to interpret this from this point plot. Let's see what we can do this for. Now let's see what we can do this. Now looking at this graph, you were saying that our graphs needs to be very beautiful. but this doesn't look like some that. So let us see what are the option does geom points take to make it much better. We'll go on to the beautification much later, but let's see how we could beautify this. So in very simple method. So geom point takes color point alpha and shape as a parameter. So color, let us provide it to be, let's say, blue, and let's say alpha, which is like how concrete the color is. Basically, if you make it less, it will be transparent. If you make it 1, it will be much more like solid color. So it values range from 1 to 0. So 0.7, let's say. And shape, it takes integer value. So let us define a integer which is multiple of 2. Let us save, control shift enter, and here instead in the shape we should give it a size. So it's taking the value of the shape. So we had a typo. Size is basically the size of this point. Now let us see if we want to have a line which determines the average value that which is moving towards this. So for this we could have smooth, which basically it sees and pattern presence over the overplotting. You will see the documentation uh, aids the eye in seeing pattern in the presence of overplotting and stat smooth and effective analysis. The both uses the same argument. Use stat smooth if you want to display the result in a non-state geom. Basically, it will give us the smooth line that which follow all the data points. So basically, we will call smooth, and here we need to provide a, let us see what will happen. Here we didn't get any line. To use the line, we need to call a method that is equal to lm, and here if you look, let us change our line color. Let us say make it red, and here we need to add addition that we missed in typo. Basically, a method we provided lm, and it points the a smoothing line throughout the data, and we could see it's clearly increasing in the expenses as age increases. Now, if you are wondering what does lm means, here in the lm, basically it's a linear model to use to generalify the data set. So here the line is used by using linear model to get this line. We have one more term that is GLM, which is generalized linear model. So in linear model, we have a error term that is a linear model equation is always a1x plus b2x plus c2x 3 plus so on, and in the end we have a error, like if the data set is not getting exact the same. So in this error we could use different error function methods, and that is generalized linear model. So you don't need to go deep into it, just you need to have an idea, okay, what lm and glm basically looks like. So if we enter, it basically will look like same. Yeah, just a little much more tangent it have in this line. You could see that it's much more above, but now let us keep it lm. And now let us define one more column. Let us say we want to get the color based on the smoker. So let us say color, and in this color, sorry, in this we provide insurance and then smoker. We need to remove this method color because it will keep all the red method. So we will see, could see based on the color. So here generally the smoker is in the blue, and they have much more expense. You could see that if the person is a smoker, it generally have more expenses compared to the age. Like, yeah, age is also increasing, but with the age you could also see that those which are smoker have much more expenses. You could see that above this 20-40K how much their expense it is. Now let's see how to use facets. Facet is a type of method that could replicate your plot once again with different variables. So to use facet, we just add one more method, facets, and this time we'll call wrap, which will just replicate the graph, and we just need to provide the variable that we want to look into. So we'll provide tilde, and in this we provide insurance and obese. And here we could see that one more observation, that the person who is obese have much more high expense rate, and they are also like smokers, fit into smoker categories, which is one of this kind of fact you could see. Now let us see how you could provide title, subtitle, plot, x-axis name, because this is not a convention name to it. So basically to use this, we could have a labs method in which we could provide title, subtitle, caption, tag to it. So we'll provide title, which is text. So we'll say insurance plot and plots, and then in the subtitle we could say plot for the graph from age 20 to 60, just a text that explain this graph. We could also name our x-axis to be age and or y. So here's one typo, we have double equal to, that we need to fix, and then y is equal to expense. With this, I think this is cool. We could run this, and here we get our title, subtitle, expense, age, and all this. Now it's time to learn about theme. Before learning about theme, we should know about what we need to do if we need to change this. So basically we need to provide one more parameter, that is color is smoker. This needs to be a string. We'll enter this. We could see this is running exactly that we need to run. Now let us see how you could use theme. So theme, you could have different themes you could play with. Let's say theme classic, and it already have some basic uh, predefined methods. So you could see that graph have gray text, and the text font already have been changed. So let us do with different methods. So let's say theme black and white. So let's check what does black and white shows. It's also same, nothing difference. theme. Let's play one more time. Let's say minimal, and see it provides you the predefined method family that they are going to use. So this is pretty much same all this because we don't have too much graph graphical notation in it. So that's why pretty much all the graphs were same. So with this we could wrap up our lecture, and here's the task assignment for you. Here is our Star Wars data set, and you need to plot similar things for height versus mass, and you need to create one more column which is twice the height of the current height, and you need to plot the similar plots that we have plot for the insurance data set. With this, I will see you on to the next lecture with the another plotting methods, that is univariant, bivariant and multivariant. See you on to the next lecture. Thank you everyone.